Good morning, everyone. I hope everyone's having a great day today. What I want to do in this video is just go through the remainder of the notes that we started in class before and just work through the problems with you so that you can kind of hear my explanations instead of just looking at a piece of paper and trying to figure out what you're supposed to be doing. Okay, so if you remember, we were talking about this method completing the square that we had started in class previously. We started that all the way back at the beginning of the year when we first studied quadratics. The main idea of completing the square is it's used to solve a quadratic equation. Okay, so any equation that has x squared in it, where you're trying, or just a variable squared, where you're trying to solve for that variable, completing the square is a method that could be used. Okay, often we talk about it being a really good method to change equations of parabolas and circles into graphing form. And a lot of times completing the square shines when y is being squared, but it also works when x is being squared. The reason for that is when x is being squared, we already have a lot of good methods. And we're going to talk about those later in this lesson, but factoring and quadratic formula are already really good methods to solve when x is being squared. Those methods don't necessarily translate when y is being squared, because when y is squared, we're usually looking for something different other than like x or y intercepts. Okay, like putting the equation in y equals form so that you could type it into your calculator. Okay, so completing the square is generally best when y is being squared. Okay, but it works on any equation when you're trying to solve for a variable being squared. Okay, so in class we had a little reminder about 5 and 6, just a little review, practicing with circles before we got into our completing the square methods. Okay, so we had started this problem in class, rewrite the equation into graphing form. There are two different ways to do this problem. Okay, since we're talking about, well, at least two that come up very easily. Since we're talking about completing the square right now, that's the method that we're going to use here. So first of all, one of the things I said in class, you cannot change y into 0 for a problem like this. We're not trying to find the x-intercepts. Okay, so we need to leave y there. So what I want to do is I want to go through my complete the square process. I want to subtract 46 on both sides. Okay, some people like to divide by 3 first. That works too. Okay, next I do have an a that is not 1, so our little formula b divided by 2 squared that we're going to be using isn't going to work until I divide both sides of my equation by 3. Okay, and this is why you can't set y equal to 0. You're going to lose this 3 if you set y equal to 0 at the beginning of this problem. Okay, 46 divided by 3, I don't think divides evenly, but I'm just double checking to make sure, yep, does not. Wouldn't want to make a mistake in the recordings. Okay, so now we are ready to complete the square. Remember, complete the square means that you are forcing your equation to be a perfect square trinomial. Because when it's a perfect square trinomial, we know how to factor it. So we take our b term, doesn't matter if you use 8 or -8, we divide it by 2, and we square it. And the reason it doesn't matter is because it's going to get squared anyway. So 8 divided by 2 is 4, 4 squared is 16. And again, I know a lot of us can probably do that mentally, meaning not showing any work. That includes me too. But I'm still showing that work so that you guys can follow along. So it doesn't look like, wait, where'd you get that 16? You should be doing the same thing on your assignments as well. So I know how you got your answers. Okay, from here, I just need to combine -46 over 3 plus 16. You can do that on your calculators here. I'll open up my calculator. And nope, it's not still there. So I'm looking to do -46 divided by 3, and I want to add 16 to that. Okay, and the reason I'm showing you this is your calculator is a tool to help you be successful. So instead of writing that decimal, we can have the calculator convert it to a fraction. I'm sure you all know 0.6 repeating is 2/3, but I'm showing you your calculator can convert decimals to fractions for you. Okay, this is what I mean when I say a great advantage to really know how to use your calculator. Okay, so we got our 2/3, so y divided by 3 plus 2/3. I'm just going to double check that that was positive. Yep. Equals x squared minus 8x plus 16. Okay, I now know that the right side of my equation is a perfect square trinomial. I know that because I forced it to be that way. So the left side I'm just going to leave alone for now. So I've got the quantity. Remember, it's always going to be the value you had up here before you squared. And it's going to follow this sign. So it's going to be x minus 4, that quantity squared. My directions tell me I'm putting this in graphing form. So I'm not going to be square rooting both sides. I'm trying to get y alone. So I can subtract 2/3 on both sides. Because again, I'm trying to get y alone. And then I'm going to multiply both sides by 3. Okay, now this right side has 2 terms in it. That's a term, that's a term. So this 3 is going to distribute to both of those terms. Over here, the 3's just cancel, so we're left with y. 3 times this quantity, I don't distribute into this quantity. Distribute means multiply, but I would have to square before I can distribute the 3 in. So I just leave the 3 on the outside. It's good because it fits the form anyway. 3 is a. And then 2/3 times 3 is minus 2. Okay, if I wanted to check, are these two equations equivalent, I would graph this original equation. I would graph this equation, and I would see that my equations overlap. And if they don't overlap, that would mean they're not equivalent. Okay, also some things to note. A in any of the forms, here a is 3, is always the same. Here, a is 3. So I kind of knew at the beginning of this problem, my a value was going to be 3 in my final answer. So that's another way you can kind of keep in mind as you're going through the problem, just to kind of see, am I on the right track? Am I going to get 3 as my A? These are all those things that like honors level students are thinking about. And I talk a lot about how we can't memorize anymore. You're working through your thinking ability, your critical thinking skills. Okay, so this one here, directions are kind of cut off here a little bit. Same thing, I'm taking this equation here, and I need to put it in graphing form, and I'm going to create a rough sketch. Now the catch here is, first of all, I have to recognize this is the equation of a circle, and that's because both x and y are squared. But the catch here is I'm going to have to complete the square on both of those variables. Because remember, in our graphing form of a circle, we have almost like a perfect square trinomial for x and almost like a perfect square trinomial for y. So that's basically what's going to happen on my circle equation. Okay, so one thing I like to do is I like to collect my x's together, and I like to collect my y's together. And I could technically add 3 to the other side, get it out of the way. Okay, so my goal here is I want to complete the square on this part so I can find its missing number so that this part is a perfect square trinomial. And I also want to complete the square on this part to find its missing number. Same thing, so that I can make that a perfect square trinomial and put that in its like binomial squared form. Okay, so I'm thinking again, I've taken my b, it's -4, taking -4 divided by 2 and squaring it. And again, the sign doesn't matter. So -4 divided by 2 is 2, well, -2, and 2 squared is 4. Okay, so this means I'm going to be adding 4 to both sides of my equation here. But I also have to do it with y. Okay, so I'm going to be doing 6 divided by 2 and squaring that, which is 3 squared, which is 9. Okay, I know we can do that mentally. Again, we're in the process of showing our understanding, because it's new understanding. Okay, it's new to all of us. So here, we're going to have x squared minus 4x plus 4. Continuing on, I'm going to have y squared, and I think a lot of you can kind of see what's happening, plus 6y plus 9 equals 3 plus 4 is 7, plus 9 is 16. It's really good for us. I now can see the radius of my circle real easily. This is also going to fit my graphing form better by adding the 3 to the other side. So now this is a perfect square trinomial, and this is a perfect square trinomial. Okay, so I can factor both of them. Remember, it's always this number before you square it, and it's always this sign. Something you don't really even think about when you get good at it. Over here, it's this number before I squared it. It's just barely showing up. Oh, I didn't think about that. I hope that wasn't cut off on the screen. Anyway, this is a perfect square trinomial. Factors as this number here before I square it, and the same as that sign, squared equals 16. Okay, so this is the first part of the question that says write it in graphing form. Second part of the question says create a rough sketch of the graph. Okay, so as I look at this graphing form, a rough sketch, remember, I think I've said this enough, a rough sketch is just one you could do on like a blank white sheet of paper. We got accurate, important points, but otherwise you're just kind of looking at the general size and shape. Okay, so both H and K are kind of like their opposite behavior thing going on. So this means the circle is going to go to the right 2. And this means the center of my circle is going to be going up 3. Or, sorry, down 3. And the radius of my circle is going to be the square root of this, which is 4. Okay, so I'm going to the right 2. I'm going down 3. I'm somewhere down in here. And then since my radius is 4, you kind of imagine I'm down 3, so 4 would be like there. 4 is going to be out here somewhere. 4 is down here somewhere. And 4, oh, this is really not centered at all. Here, let's make this a little better. If I'm calling this distance 4, then I need my y-axis to be way closer, so that this can be like 4 here. And again, that's what I mean by rough sketches. It's not supposed to be perfect, but it's not just like close your eyes and draw the graph either. It should just be somewhat accurate. Connect the dots to make our circle, and our circle is going to look pretty bad. I'm drawing with a mouse, and it's just hard to draw a circle in the first place. Okay, I mentioned before about the center is not a solution to our circle, so it's best just to label it. It's an important point. It helps us to draw the circle. And my center's at 2, -3. Not a bad idea to put the radius on either. Think of radius almost like asymptotes. It just helps you to see how big that circle truly is. Okay, we should get the main ideas from the picture, but we don't care about the like important details. If we cared about the important details, then we would say make a regular graph. Okay, rough sketch gives us the general idea of what's going on there very quickly. Okay, Okay, so converting an equation of a circle into graphing form is an excellent, excellent use of completing the square. Okay, it's a generally very easy process when you complete the square. Look, I did it in like 2 steps minus my side work. Okay, then we have this word problem. This is actually similar to a problem that you did on a graded assignment previously. So if you were working on your own on these notes, you probably found this problem to be pretty easy. And that's because you've already experienced it a little bit. So it says Scandal Math is a company that profits on writing math problems based on bad information posted online. And I'm sure there's tons of sources of bad information online for things like this. Their profit can be modeled by the equation P of n equals the opposite of n squared plus 10n, where n is the number of problems sold and P is the profit in millions of dollars. Find the maximum profit of this company. How many problems must they sell to attain this profit? Okay, so it's a real basic problem. We're thinking about maximum profit. To me, this screams look at the vertex, because I'm looking at a quadratic equation where a is negative, so my parabola is going to open downward. Okay, so to do this, I want to type the equation into my calculator. Negative x squared plus 10x. And basically, I'm just looking for where is the vertex. So I'm just going to graph it. Might need to change my scale. Looks like I do. Okay, I did type that incorrectly. Negative, yep, okay. So I'm gonna have to change my scale. I don't know what's going on here. Maybe I try zoom fit, that's zoom 0. You can see zoom fit didn't really help me too much, but it gave me an idea on what's happening. I don't need to see quadrants 2 and 3. My vertex isn't over there. So maybe I make them a small part of this graph, -1. I do need to see more of quadrant 1 though. So maybe 20. Maybe I count by 5, I don't know. Don't really need to see much of quadrant 3 and 4, so my y min, maybe just -10. Y max is probably okay. It looked like the vertex was just to the right more. Maybe I scale by 5 there. This is just guess and check though. I'm just guessing and checking until I find my vertex. Okay, there's my vertex. In Algebra 2, we don't have a mathematical way of calculating the vertex. I mean, I guess we could just use the vertex formula and not even bother with graphing this. Or you can make a graph. Okay, so I guess that's a good thing to talk about both. You're going to talk more in calculus class about why that is the vertex formula, why it works. Okay, but for now, we're not in calculus class. You don't know about derivatives. So we're just going through one of 2 ways. Use the vertex formula or make a rough sketch. Okay, if I'm going to be finding the maximum, remember I got to go left bound, right bound. So I picked the option for maximum. I've moved my cursor here to the left. I'm pressing enter. I'm going to move my cursor to the right. Press enter. And then the guess, just, you know, whatever. There's only one vertex, so no big deal. So numbers like this probably are due to math rounding error. Okay, and you could check that mentally. You see y is 25. So if I plugged in 5 for x, or n, you'd have 5 squared is 25. Negative 25 plus 50 is positive 25. Okay, so my vertex is going to occur. So if you're using your calculator, so let's look at this 2 different ways. If you did this on your calculator, a really good way that you can show your work is to include a rough sketch. Okay, it looks like I have a x-intercept at 0. Looks like I have another x-intercept at 10. So I can just have something kind of like this. I label my vertex. As being, what did I say, 525? And then I just answer the question. This is what I mean by answer word problems with words. Give an answer that answers what's being asked of you. Okay, find the maximum profit of the company. P is the profit, so Y is the profit. So this is my profit number in millions of dollars. So there's a lot of profit for Scandal Math to be making problems based on bad information. And how many problems must they sell? N is the number of problems sold. So they only have to sell 5 problems to make $25 million profit. Scandal Math must sell 5 problems to make $25 million profit. That's a gigantic amount of profit. So study your math. Not that this is a real problem, but there's obviously profit to be had in fake news. Okay, as clearly it happens all the time. With ad-based internet, that means clicks are all that matters. So one way to do this is you could use your calculator, draw the graph, make a rough sketch that counts as showing your work, and then there's your answer because you know you're looking for the vertex. The other way is just use the vertex formula. Okay, do b divided by 2 squared. So if I'm going to use a formula, I want to write that formula first. Again, this shows your dedication to letting others understand I'm finding the vertex. It's an x, or in this case n, negative b over 2a. So b here is 10, so it's going to be negative 10 divided by 2 times, I think it was negative 1, negative 1. So we're finding x is 5, or n is 5, whatever. Maybe we should be specific about it. There's no x in this equation. I then want to find p as well. So p of 5 is negative 5, opposite of 5 squared, plus 10 times 5. And I kind of already went through this very quickly. I wish I could write faster. So I got negative 25 plus 15. It's 25. No big deal if you fast forward it there. I got you. And then it's the exact same sentence for your ending. Okay, we know 5, we know 25. We make sure we understand the context. That is just n is the number of problems, yeah. Doesn't say in hundreds of problems or anything. So 5 problems make them $25 million. Okay, so we're just going to kind of summarize what we now know about quadratic equations. Okay, the 3 algebraic methods. So we're not talking about using a graph. We're not talking about using guess and check. We're talking algebraic methods to solve a quadratic equation. Remember, solve means gets a variable alone. First method is to factor and use the zero product property. You guys know that you factor the equation, you take all the factors, you set them equal to 0, and then you solve each factor. Second method is quadratic formula. Okay, and you've really studied a lot of quadratic formula. You know about the quadratic formula. I do recommend, if you're looking for x-intercepts on a normal parabola that doesn't factor, that you just use the quadratic formula. Okay, but some students have been using complete the square, and that's great. Okay, you certainly don't have to. Some people prefer it. Okay, all 3 of these accomplish the same thing. It's just a matter of what's going to work. If something is not factorable, obviously you can't use method number 1. Okay, if you like complete the square more than the quadratic formula, use that. If you like the quadratic formula more, use that. Okay, very often directions don't tell you what to do. They just tell you what they need. Okay. And then we just have these remaining problems that we did previously in class. So these are really good practice problems to see, can you still do this? Okay, I'm not going to go through that in this video here. It's already 25 minutes long. But I will post answers probably, I guess, to this so that you can see going through it as well. Okay, so if you remember, well, I guess we'll talk about it. Yeah, it says it right here. If you remember, completing the square is what created the quadratic formula. There was no quadratic formula before until people used completing the square to invent the quadratic formula or discover it. And then number 12 is just kind of like an application of, if you're someone who has to create a situation. Okay, maybe some of you want to be math teachers when you grow up. A lot of times math teachers will have a goal in mind when they're making a test. Things like, I want this problem to have two imaginary solutions so I can check and make sure my students also know how to simplify I. Okay, you saw that on your last graded assignment. So things like this. So sometimes math teachers will just guess and check until they have an equation that has imaginary solutions. Or sometimes they'll think about it in general. They'll put an extra parameter into an equation. Okay, I want an equation where students have to divide by 4 so that they remember A has to be 1. And I want a problem where they have to do B divided by 2 using a fraction. And I want my problem to have imaginary solutions. So it's real easy to just pick a number for A, pick a number for B. That forces my first 2 requirements. And then my third requirement, well, maybe I just set up something like this. Solve for C, and then just pick a value that gives me imaginary solutions. And then I create that problem, put it on like a quiz, a test, graded assignment, whatever. Okay, so that's really it for today. Yes, I assume we'll be back into class. So Wednesday is your normal like asynchronous day. I have some just a small assignment that you're going to do on Wednesday. Not going to be counting for a grade. It's also where we'll do like course selection stuff. And then Thursday we'll probably be back in normal classroom. Okay, so I hope this helps, and have a great day.